Welcome back to the lesson. This is Mr. Wong. Today we're going to be covering Module 3, Waves and Thermodynamics. Inquiry Question 5, Thermodynamics. These are the dot points we're going to be covering in today's lesson. The objective of the lesson is to investigate ways in which energy is transferred, specifically heat energy. The success criteria is to quantitatively analyze the thermal conductivity of various objects. Looking at the method of energy transfer, there are three types: conduction, convection, and radiation. You can sort of see what we're alluding to with this animation here. So, just a quick recap on how heat energy is transferred, or how heat is transferred, because heat means transfer of thermal energy. We said that from before, using the formula of specific heat capacity, or using the formula with specific heat capacity, we said that the overall amount of heat that is transferred from one object or another, or the total quantity that's held in an object, is dictated by the mass, the specific heat capacity, so how much heat the object can hold on to, and then the change in temperature. So this is how much heat energy or thermal energy is stored inside an object. Let's look at how that heat can then be transferred from that object to another object. So there's three types. You have solids, which goes through conduction, so transfer heat through conduction. You have convection, which is what liquids and gases do. And you have radiation, which radiation is obviously a type of or another way of saying electromagnetic wave. So they don't need a medium to travel through. Now, getting back my laser, if you're looking at an example where you can see all three, when you're cooking, okay, or when you're trying to boil some food, that includes all three types of heat transfer. You've got radiation from the flame if you are using, a gas top. You have convection current inside your saucepan where the heat is going up and down, or the heat is being transferred up and down. And you have conduction. So the reason why the pan gets warmer is because of the heat is making contact onto the air particles where the fire is coming from, is making contact with the metal, and the metal is making contact with the water. That makes the water become warmer. So let's start with heat by conduction. What does that actually mean? So heat transfer through direct contact between objects, that's what we refer to by heat by conduction. In the way that it works, heat transfer occurs from the hotter object to the cooler object. Now, in that case, if you're just holding a singular object, it could be from the side that has a higher temperature to a side that has a lower temperature. So we can say that it is from high temperature and it moves to the lower temperature. Now, the way it works is through collision of particles. It can come in different forms. It can come in the collision of atoms or compounds or molecules, or it could also be through the motion of the electrons across, for conductors in this case, through the metal. If we have a look at a way of imagining it, conduction is all about collision. So when particles collide with other particles, it's firstly transferring kinetic energy. Remember, kinetic energy is directly related to the temperature of the substance, so the average kinetic energy. So if kinetic energy is being transferred from one particle to another, we're increasing the overall energy of that specific particle, and that means it will vibrate more, and so as a whole there's a much larger amount of thermal energy. You can also see it here if we're looking at maybe a metal lattice. So you have one particle that's vibrating, it makes contact with the adjacent particles, and that's going to cause the adjacent particles to also start vibrating, and then also transfer some of that kinetic energy to other particles, and overall increases the total heat energy or thermal energy of the structure. And when it comes to heat transfer, the amount of mass you have does matter. So if you mix two different objects of two different liquids of different temperatures, that will affect the overall amount of heat that is transferred through, as in comparison where you put it into a big jug. When we talk about conductors, we also can talk about insulators. Now, conductors are really good at transferring heat. They're also really good at transferring electricity. Insulators are what we call a bad conductor. They are terrible at transferring heat. Here are some lists of really good conductors. Here are a list of really good insulators. The reason why I put this image here, what we call the firewalk, is because it's a really good way of explaining heat transfer. I'm not saying you should go and do a firewalk, but the firewalk does demonstrate nicely what a good conductor and insulator can do. So down here, in some countries they do a ritual where they require the participant to walk through what they call a pit of fire. Now that pit of fire, quite a lot of people can actually do it perfectly fine without harming themselves. The trick is to walk at a steady pace and, walk at a steady pace basically. The reason being is because the covering, although you see all these flames, the bottom cover has a lot of insulating material on it. So a lot of this stuff they have here is like ash, dust, or charcoal wood. So long as you don't stick your feet in there for too long, and you're continuously walking, there is not enough time for the insulator to pass on that heat energy into your feet. And that's why you don't feel that burn if you are walking at a steady pace across. Now, if they put a conductor, on the fire pit, then, that's just the end of you. Don't even try. So, yeah, enough said. Okay, so the next one we have is heating by convention. The idea of convention is the liquid or the particles in its liquid state will begin to have this sort of circular motion in the liquid. And the reason for that is because at the bottom, so I might just draw out the diagram. So at the bottom of the substance, where it's getting warmer, the particles will begin to vibrate more violently away from each other. So if we add the flame there, when it vibrates more violently, they're going to try and spread away from each other. So they're going to become, in this case, they become less dense. And if you recall what we talked about density, the less dense objects tend to go up to the top of, the solid or liquid, depends on what you're talking about. So it becomes less dense at the top, and it's highly dense at the bottom. So because of that increased amount of energy, these particles have more energy to vibrate, they're going to separate from each other, and they're going to go up to the very top. Now, assuming that you have like an open lid, the water molecules can come into contact with air molecules, so conduction there, and they can pass off that energy. Once that's occurred, they then cool down. So if you lose some kinetic energy, you vibrate less, and then you come back down to the bottom here. So this is the process of convention. The process in where particles get hot, become less dense, they cool down, and they become more dense again, and the cycle repeats itself. You can demonstrate that using this little example here. You can use a couple of different color dyes, and it can show you the different kind of convections or convection currents you can see. You can also do this with some simple beams, does the same trick. This is a really important process because it governs the way the tectonic plates function on Earth. So the fact that we have volcanoes, tsunamis, earthquakes, that's because underneath the surface of our planet, so let's say we draw Earth, then we have the crust. Underneath the surface of our planet, we have these convection currents rotating along and, basically giving our planet a new look because it's recycling old geology rocks, and it's also creating all these volcanoes, earthquakes, and other natural disasters at times as well. Alright, so as we said, another way of picturing convection is just what happens. So if you put heat into the object, the particles begin to vibrate, they gain more energy, they'll try and spread away from each other. So that's why they rise to the top, because they become less dense. When they go to the top of the container or whatever you're putting in, the heat will escape, basically. That could be in the form of collision with air particles, and then it loses energy and it sinks back down because it's more dense again. So that's the idea of how we can use convection for cooking as well. Alright, next we have heating by radiation. So heat transfer in this case doesn't require particles, but to be more exact, the definition we're using, it doesn't require a medium, so location of particles. And that's because this form of energy transfer is through electromagnetic waves. And electromagnetic waves only need oscillating electric fields and magnetic fields in order for it to continuously move. So that's not an issue there. Examples of heat by radiation is infrared waves or ultraviolet waves. Infrared is the most common, so when you turn on the stove from a gas cooktop and you feel the heat coming towards you, that is infrared radiation. That's heat by infrared. You can actually demonstrate how heat is transferred by using what we call infrared cameras. The human body, we naturally radiate out heat in the radio or infrared range of the electromagnetic spectrum. So what that means is we have radioactive properties, we are emitting radiation, but we don't emit visible light. If we did, we'd be glowing all these different colors of the rainbow. But if someone had infrared abilities to detect the radiation coming out of your body, they would actually see your image in this kind of contrast. Obviously, the color saturation is to give you that idea. It doesn't mean that if you saw an infrared, you'd see the rainbow. No, but you'd be able to detect it visibly. You can actually see this in different parts of the body. So your head tends to be, as you can see in this image here, your head tends to be a lot more warmer than other parts of your body because that's the function of your brain and all that. And then as you can see, if you have a hot mug, it's a much lighter color. So the lighter colors represent the higher temperatures, and the darker colors, like blue in this case, represents the colder colors. So just to quickly summarize what we said, conduction occurs in solids. That's due to heat transfer through direct contact between objects, more specifically collisions between particles. Convection occurs in liquids and gases. Heat is transferred by changes in density in the particles and when heat is introduced and released. And the last one we have is radiation. That doesn't require medium. It's emitted through electromagnetic waves. So radiation can occur, goes through solids sometimes, can go through liquids and gases. So radiation can occur for any form of state of matter. Not that the actual substance allows for the radiation to occur, because radiation just occurs by itself through oscillating electric and magnetic waves. Conduction and convection needs a specific medium in order to transfer that energy. So there is that. All right. So that concludes this component of the lesson. We've basically summarized the process in which heat is transferred by conduction, convection, and radiation. The next part of this video essay, we're going to look at a concept called thermoconductivity and how heat is transferred between conductors. Now, thank you for joining me in this part of the lesson. Join in this video link over here, and also look into thermoconductivity.